Hello, class. Okay, last time we started with chapter 2 and we did a bit. What I want to do today with this video is to quickly go through what we did on chapter 2 and then add one more concept so that you can do the next homework. So, chapter 2 is about forces. Okay, forces are vectors. Because whatever we do to force as a vector apply to other types of vectors like acceleration, momentum, and so on. Okay. So we're going to use, remember this class is about statics, and statics deal with objects in equilibrium under the action of forces. So forces and general normal, I like to say loading, forces, movement, torsion, etc. So what I did was to talk about a vector quantity, the different types of vectors, and so on and so forth, how vectors are denoted or represented. Okay, every vector has a magnitude and kind of direction. Okay, and I normally say when you write it with your hand, you might end up putting an arrow on top to show a vector. But in a textbook or a handbook, you might see that vectors are bold. Okay, so we went through this. And then I talk about, okay, you guys have done vectors at your high school. So maybe if not 3D, at least 2D vectors. So we can have negative vectors, a vector, and then it has its negative. We talk about triangle law, what is a resultant vector, power vector, and so on and so forth. But one thing of interest was the triangle law or the parallelogram law. The triangle law is just half of the whole parallelogram. We can do this graphically. We can add vectors in particular forces graphically. Okay. And that is if you have a pencil and a ruler, you can be drawing your vectors at an angle and then use it to find the resultant. But we are not doing that here. What we did was we use that to do it analytically. But before then, we need to know a bit of cosine rule, sine rule, and so on and so forth. Okay, so we went through cosine rule, sine rule, and then we would to apply them. So what we're doing here is, so we could do this by skill, but we're not doing by skill. We're still doing it by hand, analytical. Okay, by hand. Graphical can also be by hand, but we're doing analytical. No, that we are calculating it. We are not doing by any skill. So in this class, I'm just teaching you how to use parallelogram law, or in this case, triangle law, to find the resultant of only two, no more than two. If you want to do more than two, it means you do two, get a resultant, and combine with the third one, and then get a resultant and get combined. But that is so tedious. We don't want to do that. So I'm only teaching you how to use the triangle law to solve only two uh, forces, resultant of two forces. Resultant means you have to get the magnitude and then the direction. Okay. So what I did in class was, let's say you have two forces, F1, F2. The angle between them is alpha. Okay. The angle between them is alpha. You can decide to, and the forces are F1, F2, that they are both, but this F1 and F2 here are like the magnitude. So you draw one of them. That's you can start with F2 and then add F2 and then add F1 to it, and then you get a resultant. By the picture here shows F1 and then you add F2, then you close it with the resultant FR. Now, in class we able to show that the angle between, or the angle that faces FR is 180 minus the alpha, where your alpha will be the angle between the two forces. Okay. Now, knowing F1 and F2, that's the magnitude, and knowing this angle means you can use the cosine rule here to compute what is the FR. That's the magnitude. Okay, that is straightforward. But the problem is that how to get a direction. How to get a direction. So to get a direction, this is the resultant in red here. So we indicate an angle beta. We indicate an angle beta. Okay. And then you use cosine rule because you don't know beta, but you know F2. You know FR now from here. And you know 180, what is whatever 180 minus alpha is. So using sine you compute beta, but please, beta is not necessarily your direction. Beta in some cases could be your direction, but it's not. So let me say I'm using theta for direction. Then you have to find a way to compute this theta. The direction, engineers like to measure direction from, let's say, the horizontal axis, clockwise, counterclockwise, or from the vertical axis, clockwise or counterclockwise, as if this way, counterclockwise, clockwise, and so on and so forth. Even if you go to in the aerospace, or if you take pilots and pilots in ships or aircraft, they want to talk about bearings. So in bearings, they measure the direction this way from the North Pole, okay, from the North Pole. So that's what they like to do, so that you can know the direction of the plane or the ship, and so on and so forth. So we did an example on this. In fact, we did both example in class. I did this one, and then we did this one together, okay, which I don't want to go through again. I believe everybody can be able to do this, okay. So what the essence of this lecture is, the next example that I'm going to talk about. Listen, we're going to do this resolving, finding resultant of forces in a different way. Okay, that is more, that one we can usually do more than two forces, two or more. But what I'm going to do next is an application of the parallelogram law or the triangle law. And that is next example or next concept we're going to talk about. You can't use resolving to do it. In fact, that's the reason why I did the parallelogram law. So let's go through. And that is what I need to do. Okay, so what is this concept? Is to resolve a force into two components. Is to resolve a force into two components. Anybody know how to resolve forces, which we're going to do next. But listen, here, the two axes that we are going to resolve along do not meet at 90 degrees. If they meet at 90 degrees, then you can use a resolving. I believe some of you know this, F cosine, F sine. Good. But you are not resolved these two. So let's say the axes are U and then a V. And I have a force here. Maybe I know one of the direction. These U axis U and V do not meet at 90 degrees. The axis U and V do not meet at 90. Listen, they do not meet at 90 degrees. And one approach that can only do this is the parallelogram law. Okay, so be very, very careful. So how do we go about it? So this is like opposite to what we did the previous one. Here, the resultant is given. Here, the resultant is given. So you know, let's say the magnitude of the resultant. You know maybe the direction of the resultant to you, or you know the direction of resultant to you. You know some angle. You know the angle of the resultant to you, or you know some angle of the resultant to V. And they want you to find what is the magnitude of F along U, and what is the magnitude of F along V. Let me put it this way. As engineer, so let's say you have some bar and it's kind of suspended here, it's fixed here, and then somebody is pulling with a force F, let's say 10 newtons. And there are two bar, there are kind of two bar here, one here, one here. You want to know the component of this alongside this bar, and you want to know the component alongside this bar. But this bar do not meet at 90 degrees. They don't meet at 90 degrees. Take note. And we use the parallelogram concept to do that. So let me clean the screen and I'll explain this. So what we do then is we still use our triangle law. This time, let's say the component of the force along U is Fu. Let's say the component along V is Fv. Okay, that's the forces, and these are their magnitude in scalar form. Okay, so you take, once again, you take one of them, you draw. Let's say I start with Fu, I draw Fu, then I close it with Fv. Oh, sorry, I draw Fu. Wherever Fu ends, you start with your Fv, and then you close it with your resultant, which is F. Okay, note, we don't know Fu, we don't know Fv, but we know F. And they will give you some angles. So hence you can know what this angle is. Knowing what this angle is, then you just use sine rule. You just use the concept of sine rule because you know what this angle is, or you know what the angles are. So let me clear the screen and then we see. You know what is A, what is B, what is C. So just using sine rule, you write a sine rule of this side to that side. When if you do the sine rule of this side to that side, and hence you've able to find the component of the resultant along two directions or axes that do not meet at 90 degrees. That do not meet at 90 degrees. So let's look at one example, and then I'll end the video. We'll continue the concept that. So this is the next example. I'm going to switch to something called OneNote, which is like a whiteboard, and I'll solve the problem there for you to see. Okay, so look at the problem here. This is a force F with a magnitude of 200 newtons, and you are pulling. You see, you are pulling this two bar. U is the direction. This in the direction of this bar. V is in the direction of this bar. So what, as engineer, you want to do is that what is the component of F alongside this bar and alongside this bar, or what is the component of F alongside U and alongside what, V? Okay, so I'm switching to OneNote, and then I'll solve the problem. This is an example in the textbook, so you can also look at it. So what do we do? So look at the picture very well. I'm going to call the force along this direction Fu, and I'll call the force in the direction F. Please, it doesn't have to U and V. It can be A and B. It can be anything. Okay, so let's take note. It doesn't have to be U and V. So you can do any of them first. Okay, you can draw any of them first. But here I'm going to draw the U first. Easy to draw. Draw the direction of the U, so that is Fu. And then look at the direction of V. So I'll bring V in the same direction. You can make it big. Let me make it a little big. So like, okay, good. And look, the resultant is which one should I use? Let me use the 600. Sorry, I will change it. It's 600. Let me use the 600. So that makes, I'll change for the lecture notes. Let me use the 600. So the resultant magnitude is 600 pound. Okay. Okay, so I think let me use the 200 newtons. The textbook uses the 600 pound. So I'll change mine to the 200 newtons. So we can use the 200 newtons to do it. Okay, cool. So 200 newtons and it's horizontal. So what will be the case? This have to be closed, and that is 200 newtons. And the arrow here, this is your FV. Now, the next thing you have to do is look for the angle. So let's see a few things. Look at this. This is quite straightforward. This angle between this U and this line is 30. So this one is straightforward to get. 30 degrees. Let's see what else we can get. Strictly speaking, look at this. The angle between V and U is 30 degrees as well. So this angle here is also 30 degrees. Very easy to find. Okay? That is, even if you extend this one here like this, and you extend this one here, this angle, I don't know whether I say alternating or corresponding angle, corresponding. So this is that is 30. So that is 30. So if 30 add 30, that is 60. An angle in a triangle is add up to 180. So 60, we take 60 from 180, you get 120. So this angle here is 120 degrees. So we got our triangle, and we just like have to find the side of a triangle. So we are finding your FU and then your FV. So it's quite straightforward. So you use sine rule. Yeah, you just use sine rule. That's all. So using sine rule, So we just use sine rule twice. Okay, using sine rule. With I'll do one of them for. Let me do FU. So FU over sine 120 degrees is equal to, the resultant is known, so you have to relate to the resultant, equal to 200 over sine 30. And then the other one will be FV over sine, of course, 30. FV over sine 30 equal to, see, this was FU over sine 120 equal to 200 over sine 30. Then here is FV over sine 30 equal to 200 over sine 30 again. So the right hand side for both equations are the same. And then at this moment, don't do anything. Just go to your calculator. Okay, you don't even need to waste too much time and rearrange. Just go to your calculator. I don't. The one in the textbook is 600 pounds. So let me just use my calculator here. Let me see, the lighting system here is about. Okay, let's see. 200 sine. Let me hope I'm working degrees. Okay, sine 120 divided by sine 30. Let me use that. Okay, I hope I'm working degrees. So 200 times sine 120 divided by sine 30. Enter. Okay, so I'm getting this. And I will tell this is a very practical thing. Let me look at, even though the resultant is 200 pounds, 200 newtons. Look, we are getting a force that the 200 newtons is generating a force that is more than 200 in each of the bars. Okay, let me write it 2 decimal places. 400, 346.41 newtons. And then the other one, I just need to change I have the 200 there, I have the sine 30 below. I just need to change the 122 to 30. And then I'll press enter again. Okay, I finished school. Okay, of course, the sine 30 and sine 30 cancel. This just come out to the same value as 200 newtons. So that is cool. Okay, and these are the components. So I'm going to end the lesson here because I just want to I'll give you 2 homeworks. One on the using the parallelogram law to find the resultant of 2 forces. The second one be using the parallelogram law or the triangle law to find to resolve a force into 2 components, and the 2 components or 2 axes, they do not meet at 90 degrees. Don't use anything else. In the next lesson, whether I'm going to record it or meet on Tuesday, I'm going to now show how to resolve, and we use the resolving to do. But you can only do resolve along the resolving that you've learned before is resolve along 2 axes that meet at 90 degrees. At that time, I believe you guys were learning resolve along the X, resolve along the Y. So that is what I'm going to end the lesson, this short lesson. I believe it is very clear, and you can be able to do the homework without necessarily explaining in class. But so if you need any help again in class, I will go through. Thank you very much. Okay, bye.